Okay, so today we have two presenters, Patrick Miller and Denise Rothrock, who will tell us about the IASC program. Take it away.
Okay, thank you, Lisa. I'm Patrick Miller. I'm with the Department of Mathematics at Hardin-Simmons University, and today I'm going to talk about debris fields in the solar system, and also talk about dangerous threats that some of that debris poses to Earth. There we go. So we'll start off by talking about some historical events, some very far in the past, some quite recent, as a matter of fact. So let's talk about Varnavar, Siberia. 7 o'clock in the morning, 7:17 a.m. on June 30th, 1908. Just a typical day, everybody minding their own business. Man was sitting on his front porch of a trading post, just minding his own business. Suddenly he was hurled from his chair and experienced heat so intense that he felt as though his shirt had caught on fire. He was standing 70 kilometers away from the airburst of an asteroid that was 40 meters in diameter and weighed about 100,000 metric tons. The airburst that took place heated the Earth's atmosphere to over 44,000 degrees for a brief instant in time. That's about 4 to 5 times the temperature at the sun's surface. And it released an explosive equivalent of 4 megaton hydrogen bombs, or on the Hiroshima-type bombs used in World War II, about 185 of those was the equivalent blast. Now, nobody, to our knowledge, was killed, except there were local deer and local elk. They were killed in the immediate blast area. And about 2,000 square kilometers of forested area was also obliterated. Some 80 million trees were stripped of their bark, just laid flat into the ground. So here's the pictorial of that. This asteroid, 30-40 meters in diameter, weighing 100,000 metric tons, comes screaming in the Earth's atmosphere. Doesn't actually hit the ground. It airburst. As a matter of fact, the airburst did more damage than if it had hit the ground, with a 4 megaton equivalent amount of energy release. Now, it took about 20 years before anybody got up to Siberia, because this was an isolated region. And of course, in 1908, when this event took place, there weren't any trains, planes, or automobiles of note. So about 20 years later, in the early 1920s, the dog sled teams went up to the site, and this picture, along with the next picture I'll show you, are from that expedition. Those are some of the 80 million trees that were flattened by the airburst. And here was the area completely obliterated, the 1,600 square miles, 2,000 square kilometers region that was completely obliterated of all trees. Now, the event's called the Tunguska event, and there it is on a map. As you can see, it's in the middle of Siberia. In 1908, still didn't anybody live in that particular vicinity, although there did live someone 40 miles away who was knocked off the chair of his trading post. But if this thing had landed not at 7 o'clock in the morning, but had landed at noon, just a few hours later, it would have airburst over St. Petersburg. Now, St. Petersburg in 1908 had over 1 million people, and that blast would have killed probably most of those people. If that event takes place over St. Petersburg 4 or 5 hours later than when it actually took place over Tunguska. Or had it hit the Earth a couple of hours earlier, at 5 in the morning instead of 7 in the morning, it would have airburst over that small fishing village off the coast. And they had 1,000 or 2 people living in that village. So we were just fortunate that the event took place over an unpopulated area. Now, had it occurred later that night, it would have landed in the Long Island area, and that was, in 1908, would have impacted 4.5 million people. And by the way, this event was a small one. Gulf of Mexico, 65 million BC. Asteroid 10 kilometers wide, that's about the size of a mountain, struck Gulf of Mexico off of the coast of the Yucatan Peninsula, and it caused a crater about 360 kilometers wide, and it penetrated as deep as 35 kilometers into the surface of the Earth and carved out this massive crater. That event is estimated to have released energy equivalent to 3 billion times the Tunguska event. So basically, imagine 3 billion 3 billion hydrogen bombs going off all at the same time, each with 4 megatons of energy. In this case, it had global consequences. The atmosphere thousands of miles away was heated at such a high temperature that any plants or animals that were in that zone were instantaneously ignited into flames and burned to death. Large amounts of sulfuric acid or battery acid was pumped high in the atmosphere. It rained down, very concentrated acid rain, and it killed plants and animals hundreds of miles away and dissolved rocks that were also hundreds of miles away from the impact site. It also placed tremendous amounts of fine dust into the Earth's atmosphere, and also had some soot from the fires that started that also were pumped in the Earth's atmosphere. And the prevailing winds over the coming weeks then would have spread that material all around the Earth. And the effect would have been to block light from the sun, darken the skies, and interrupting the food chain by stopping photosynthesis. And that would have taken place for several months, where the surface temperatures would have dropped below freezing. Now, when the skies did clear after that soot and dust finally settled down to the ground, the event also pumped into the atmosphere tremendous amounts of water vapor because it landed in the Gulf of Mexico, or it's the Gulf of Mexico today. And it also landed over, or impacted over, a limestone deposit and pumped large amounts of carbon dioxide into the atmosphere. What that would have done is caused a fluctuation in temperature in the other direction, where it became the temperature became boiling and not freezing. And this huge fluctuation of temperature destroyed plants and animals all over the Earth, not just in the impact zone, where most of the devastation took place, but the effects were global, were worldwide. And it's estimated that 50% of the life on Earth died as a result of that mountain, that asteroid mountain impact off the Gulf of Mexico. And including, current line of thought is including the dinosaurs, although I've heard several geologists argue otherwise. But we do know that the dinosaurs show up in a record below this event and don't show it in the record above the event. So we think that that's a contributing factor to the destruction of the dinosaurs. So this is what it looks like today. It didn't look like this 55 million years ago, but this is what it looks like today. And there's the Chicxulub Crater, or the Chicxulub event is what we call this, because that's the nearest city. And you can see that crater is overlaps the Yucatan and also the Gulf of Mexico. So a massive tsunami would have swept throughout the Gulf of Mexico from the impact. Plants and animals hundreds of miles to thousands of miles away would have burst into flames because of the intense temperature. Acid rain would have come down and dissolved the rocks and killed the plants and animals. Here is some geological sampling sites around that crater, showing you where they have found material from the impact. Actually, what they found were impact materials. These are little glass beads that were blown out, blew up in the atmosphere as molten material, and then when they fell back into the atmosphere, they quickly cooled down and showered these glass beads thousands of miles around that site. So you might say, well, why should I be worried about this? If you know who this person is, then I think that tells me how old you are. Denise, do you know who this person is?
No.
Okay. That's Alfred E. Newman from Mad Magazine. Anyway,
Okay.
His famous saying is "What Me Worry." You might say, well, the event that could have destroyed a city, a major metropolitan area like Dallas or New York, that took place in 1908, that's over 100 years ago, and the event that destroyed half the life of the Earth took place 55 million years ago. So why should I be concerned about this? Well, let me introduce you to a topic. In fact, you can see this. This is 3 pictures taken of this asteroid, taken over about a 1 hour time period, and then the pictures are lined up off the star pattern. And near the middle of this, you can see the asteroid moving across the screen. Here's the orbit of Apophis about a year ago, showing you, here's Apophis there, and there's the Earth in its orbit. And right now, they're separated, and on this particular day, they were separated by about 50 million miles. However, on April the 13th, 2029, Friday, you'll find Apophis here. If you look behind it, you can see Earth. So on that particular day, Earth and Apophis are going to be at the same place at the same time. And Apophis will pass within about 20,000 kilometers of the Earth's surface, and that is closer than some of the, it is closer than the geosynchronous satellites. 7 years later, April 13th, 2036, let's talk about Apophis and the likelihood that it may impact the Earth. It's about 300 meters across. That's about the size of 3 football fields. And if it were to hit the Earth, the impact event would be equivalent to 130 Tunguska events. Remember, one Tunguska event would have destroyed New York City or destroyed St. Petersburg. This would have a regional consequences. This landed in Texas, for example. It would affect all the major metropolitan areas of the state, not just the place where it landed. So will Apophis hit the Earth? Yeah, probably will. Most likely will hit the Earth. Will it hit the Earth in 2029? Probably not. But I've got to tell you, there's enough uncertainty in the knowledge of Apophis' orbit to give it a possibility, a very slim possibility, about 1 out of 80,000 chance, that if it passes through a particular region around the Earth called a gravitational keyhole, its orbit will in fact be changed in such a way that it will in fact hit the Earth 7 years later when it sweeps by the Earth one more time in 2036. And this is the dotted or the red dotted region that you see there is where this particular asteroid would hit somewhere along that dotted red line. All I can tell you is that if Apophis gets its orbit changed in 2029, just a few years from now, and 2036, 7 years later, impacts Earth, you do not want to be standing anywhere along that dotted red line. Likelihood, about half of this you can see is over the Pacific Ocean. So that's probably where it would hit, although it could hit over Siberia, or it could hit over a land area here in Latin America and the northern South Africa, just off the coast of Africa. But probably will probably hit there, about a 50% chance of doing that. If it does that, then that will cause tsunamis that would sweep the Pacific Rim, destroying the western coast region of the United States, destroying Japan, and destroying some of the New Zealand and some of the other land masses that you find in the South Pacific. Let's talk a little bit more recently. Planet Earth, February 15th, 2013. That's about 6 weeks ago. That time was last week. But when I wrote this, 6 weeks ago, the whole world held its breath as an asteroid designated 2012 DA14 passed within 22,000 kilometers of the surface of the Earth. That asteroid was 40 meters in diameter, and which makes the size of the Tunguska asteroid that airburst over Tunguska Night Lake. And it also passed closer to Earth than many of our communication satellites. Had that asteroid arrived 15 minutes later, and it would have in fact hit the Earth's surface. Like I say, the event would have been as powerful as the Tunguska event. It turns out its trajectory was actually under the Earth's south pole, so the only land masses that would have been threatened had there been an impact probably been Australia, maybe southern parts of Africa. And had it landed in a large metropolitan area, just like Tunguska would have done, it would have killed millions of people. So give that some thought tonight when you're lying down trying to go to sleep. Here's a photograph or an image of the the orbits of that particular asteroid, where it was on February 15th. And as you saw, the one I showed you at the top, that asteroid and the Earth are at the same place at the same time. You'll also notice that it will cross the Earth a couple of times, and so the close pass will be repeated time and time again over the years. So it's just a matter of time before it actually. That was last week or last month. On that same day, a few hours earlier, in Chicxulub, Russia, 9 a.m. in the morning, start of a school day. The same morning that DA-14 just missed the Earth for 15 minutes, an asteroid that was 17 meters in diameter, weighing at 10,000 tons, airburst very close to that city. The airburst produced a shock wave that blew out windows and doors, and also collapsed walls of some buildings, brick buildings that were in the city. Over 1,200 people were injured, requiring medical attention, mostly by the flying glass and other debris from that shock. The explosive power, again, of that event was the equivalent of a small nuclear weapon, a small nuclear bomb, going off about 60 kilometers in the air above the city. Matter of fact, some people thought that's what was happening. They thought that there was a nuclear war started, and it was a bomb that exploded near the city. First time in recorded history that I'm aware of that a large population of people were injured by an exploding asteroid. And so had this thing been a little bit closer to this city in Russia and not been off 60 kilometers away where it airburst, people would have in fact killed. It could have been much, much worse than what it turned out. And I can say that was just 6 weeks ago. So this is a very real threat. This debris from this asteroid debris that wanders in and around the Earth does hit the Earth all the time, and sometimes big pieces come through and pose a global-wide threat. More frequently, pose a regional or a citywide threat. Here's some pictures of the one over Russia last month. There's the actual airburst taken from somebody's dash cam. There's the contrail, or whatever, I guess, the struck to the atmosphere after it, or flew through the atmosphere after the airburst. Here you see, this was in a foyer of an office complex, and you can see the glass shards all over the floor. And there were people in that foyer at the time that this happened who were injured by the flying glass. There's a factory whose brick wall was collapsed as a result of shockwave. And here's actually a photograph taken, I'm not sure from which satellite, it was taken from above the Earth, and you can see near the center here this bright light streak. That is the Chicxulub meteor or asteroid coming in and airbursting over that.
I love the fact that the weather satellite caught it. That's just fabulous.
Is that a weather satellite? Yeah. Okay. Yeah, you're right. Well, let's talk a little bit about what these things are that are airbursting over cities and posing threats to us here on the surface of the Earth. And as this is just much of a natural disaster happening on the Earth as a tsunami, killing tens of thousands of people, or earthquake destroying half Japan, and tearing down some of their nuclear sites, this is a very real threat. Only this is the kind of threat that we can actually predict in advance. So we're talking about objects that look like this. Now these are larger than any of the ones that have hit the Earth in recent times. And Phobos, actually, this is an asteroid that doesn't threaten Earth. It's not near the Earth. It's in orbit about Mars. But I wanted to show this because this is about 16 miles across. Eros, which is the second switch over, we've been to Eros. We've, I think in 2000, 2001, the nearest spacecraft went out to Eros and surveyed the asteroid. And then they actually dropped the spacecraft on the surface of the asteroid where it transmitted for a few seconds thereafter. The long side here is about 20 miles. The short side here is about 5 miles. Two others are Gasper and Ida. Ida, in fact, has a small companion. It's what we call a binary asteroid that they call DAC. And so these are large rocks, boulders of rock, some quite hefty in size that we're talking about here. Here's a flyby, I guess, on September 19, 2000, of the Arrow spacecraft that flew by the NEO near-Earth object Arrow. Now here's an image, probably the one on the bottom here would be a little bit easier to see and understand. This was, each green dot represents a known asteroid in the Minor Planet Center database as of September the 23rd, 2000, at Universal Time 1219. And you'll notice that this debris forms a ring around the sun, sort of a donut or core-shaped region around the sun. And it's located between Mars, which is this orbit here, and Jupiter, which is the outer orbit. But most of this stuff arcs out from the sun anywhere from 2 to 4 times, 2 to 4 astronomical units, or 2 to 4 times the distance between the Earth and the sun. But if you look carefully, you'll see a few green dots over here and a few green dots over there that are in Jupiter's orbit. Those are called the Trojans. Those have actually been pulled out of Jupiter's orbit out of the orbit of the main belt by Jupiter. And if you look more carefully in the interplanetary system where we live, you can also see some green dots there as well. There are literally thousands of them that have been dislodged from the main belt, primarily by Jupiter, and they're either pulled outwards or they're shifted inwards, and they come inward, and when they cross Earth's orbit, we see those, and those are the ones that the air burst over Chile Blinks and hit and devastated the dinosaurs, and air burst over Tunguska and knocked the guy out off the air 40 miles away. That's referred to as the main belt, the main asteroid belt. The NEOs then are asteroids that were originally in the belt that had been dislodged gravitationally by Jupiter and sent inward and crossed Earth's orbit. Those are the ones that pose impacts with Earth. So now here you have what we call the Trojans. These are the ones that have been pulled towards Jupiter that are actually in a region around Jupiter orbit, ahead and behind the orbit. But the main bulk of this material poses no threat to Earth, and it's located between 2 to 4 astronomical units from the sun, and that's what we identify as the main asteroid belt, or just the main belt.